I'm doing it at point P, the tangent line there. Same thing. However, I'm wanting to go to a secant line. Well, here's another way to think about it. Let's say I go out h units to get my secant, my second secant point, if you will. So I'm going to go out here to get my second secant point. So that gives me, I'm going to go out h units to that, which that puts. So that puts it. If I go out this way, that puts this x value to be what? It would be a plus the h. So that's a plus h right there. Okay, so here's what it is then. All right, so we've got p still, that's function f. So p is still what? A comma f of a. But now what is q? Well, q would be, like we said, the x value is a plus h, and then the function value would be f of a plus h, wouldn't it? With me on that? Okay. All right. Okay. So now what is the slope of these secant lines, or this secant line, going to be? Well, difference of the x's, which f of a plus h minus f of a, right, over, now what's the difference of the x's? Well, this x is a plus h minus this x, which is a. What happens? Yeah, just h on the bottom. So the MPQ is just f of a plus h minus f of a over h. A little different than the other MPQ was, but it's the very same idea, isn't it? Now, if I take the limit of this, and let these increments get smaller, h get smaller and smaller and smaller, what is that going to give me? That's going to give me the slope of the tangent line. Right? Now, the thing of this one is, what's happening here is the h is getting smaller and smaller and smaller. So I'm letting h go to something. I'm letting the h get smaller and smaller. So what would I want h to go to? How about 0? Okay. Yeah, I want the h value here to shrink smaller and smaller and smaller, so I want the h eventually to go to 0. So that's the limit here. It's not x going to a, it's h going to 0. This is also another way you can find the slope of the tangent lines. And it's known by equation 2, they'll call it. So if it refers to use equation 2, this is what it means. Okay? All right, so let's use that to find, use equation 2 to find the slope of the tangent line. For y equals x cubed at 2, 8. Using equation 2. All right, so slope of the tangent line using equation 2. All right, so it's the limit as h approaches 0 of f of a plus h minus f of a over h. And again, A, let's label it out first. What is A? A is what the x value is here. So A is 2. It may say A is 2. But if it gives it a point, the x value is the A. 2, 8. All right, so let's do that. Let's replace the A by 2. All right. Okay. Let's go up here. So I've got the limit as h approaches 0. All right, so what is f of 2 plus h, first of all? Well, again, since this is my y equals x cubed, that's my function. That's my f of x. F of x is x cubed, also known as. Okay? Means the same thing. Y equals x cubed. They may give it in the function notation, but they may not. Probably some of them don't, since I've done it like this. All right, so what is f of 2 plus h? Well, that would mean replace the x by 2 plus h. That would be 2 plus h cubed. Is what f of 2 plus h would be. Now, f of 2, that's a little bit easier. F of 2 would be 2 cubed, wouldn't it? And then the bottom just stays as h. So guess what I have to do for this limit? Well, I'll do a little bit of cubing here. 2 plus h cubed. Two plus h 3 times, unless you know the shortcut there. 2 plus h times 2 plus h, that gives me 4 plus 2h, and 2h is 4h. H and h is h squared. So those two give me that. And then take those and multiply by 2 plus h. So that gives me 4 times 2 is 8. That'll be 4h. Then the 4h times 2 is 8h. 4h and h is 4h squared. 2h squared. And then plus h cubed. Yeah, I'm on there. Okay. So altogether I get 8 plus 12h plus 6h squared plus h cubed. Is that okay? Did I do that right? I think so. Okay. So that's 2 plus h cubed. So I get the limit as h approaches 0 of this 8 plus 12h plus 6h squared plus h cubed minus 8. Minus 8 from that. What happens? The 8's go out. 8 minus 8. What else? Factor. Now I have a common factor. I can take out an h. So that'll be h times 12 plus 6h plus h squared over h. The h's cancel. Now I can do my limit. So the limit here will be 12 plus 6 times 0 plus 0 squared, right? Because h is going to 0. I get 12. And what I find, that's the slope of the tangent line at 2, 8. Slope of the tangent line at 2, 8. Okay? All right. Everybody okay on that one? All right. Now, what we'll also do is this one. Find the slope of the tangent line for y equals x over x minus 2 at 4, 2. We'll do one other. Okay. This one, we have two options now. We have definition 1, we have equation 2. We could use either one. The book, I'll probably specify which one to use in the homework, but you'll use both. But what I would say is, from this point on, or after we get through with the first test, we'll probably be using more equation 2. Okay, so that's the one we'll more specifically do. So I just want to mention that. Let's use equation 2 again for this one. So equation 2 says the slope equals limit as h approaches 0, f of a plus h minus f of a over h. So that's the limit as h approaches 0 of, in this case, f of a plus h would be, plug in the a plus h for x, so that would be a plus h over a plus h minus 2. Oh, and I forgot, we do have a here, don't we? A is 4, so let's replace the a by 4. So it's 4 plus h, 4 plus h minus 2. We do know a is 4 here. I was thinking a little far ahead there. All right. We do know a is 4, so it's 4 plus h over 4 plus h minus 2. F of 4 then would be 4 over 4 minus 2. And then we still have over h. All right, so that gives me the limit as h approaches 0 of, now this is 4 plus h over, that would be 2 plus h. And that would be 4 over 2, which, right here? Oh, yeah, I'm plugging x to be 4 on this one. So you got 4 over 4 minus 2. The x is 4. A is 4, so plug in x to be 4. Okay, so this one, how do I do that one? So here's our limit. How do I do that one? Well, the way we did that one is we kind of did some combine these fractions here. You can reduce that one. I'm going to leave it alone though. Well, no, let's go ahead and reduce it. Let's just go ahead and reduce it. This one reduces. 4 over 2 just gives me 2. So yeah, now I combine these fractions. Yeah, either way. If I combine these fractions, what would I have to do? Well, the only denominator up here is 2 plus h, so I need to multiply this one by 2 plus h over 2 plus h. That being 2 over 1. So that'll give me then a common denominator of 2 plus h on the top, so I can combine tops here. Now this will be, remember the minus 2 is times the 2 and times the h, so it'll be minus 2 times 2 will be minus 4, and then minus 2 times h will be minus 2h. And then the denominator would be 2 plus h. Then also remember what I did with the over h Didn't I say that's times, well, let's just leave it that way first of all. It's over h. So this works out to be the limit as h approaches 0. 4's cancel. H minus h is minus h. So I have minus h over 2 plus h. But then the, we said the divide by h, we multiplied that by 1 over h to do that, because then we can cancel. So that gives me the limit as h approaches 0 of negative 1 over 2 plus h finally. But h is going to 0, so what does this go to? Negative a half. There you go, okay? This slope of the tangent line is negative 1/2. All right. But really, you know, this, calling this the slope, is really all that's new. We've done these limits, all these limits, we've done these before. We're just now noting that this equation here gives me the slope of the tangent. All right, now, the other thing we might encounter is this. Let's find the slope of the tangent. For f of x equals the square root of x at x equals a. In other words, we're going to do this one in general. We're not going to say what the a is. A could be 4, it could be 6, it could be anything we want a to be. So we're just going to do this one in general. We're just going to leave the a in there. Okay? And again, let's use equation 2. We could use definition 1, but let's try equation 2 on this. All right? So equation 2 tells me that the slope of the tangent equals the limit as h approaches 0, f of a plus h minus f of a over h. Okay? Well, in this case, I don't have an a value number to plug in. I just have to leave it as a. So I don't have a as 4 or 10 or whatever. A is just a in general. So f of a plus h, that's what I'm stuck with. What is f of a plus h in this case? Well, this means input a plus h back in my function. So what is f of a plus h? Square root of a plus h. I don't have a number for a, so I'm stuck with f of a. So I'm going to input a for f of a. What is f of a? Yeah, plug in a, all right? Square root of a. And then that's all over h. Okay. No big deal, right? I can do that. How do I do that? How do I do that limit? Well, it's a square root limit. How do I do the square root limits? We did the conjugate. Multiply top and bottom by the conjugate of the top. Square root of a plus h minus square root of a over h. I'm going to multiply top and bottom by what? Square root of a plus h plus the square root of a. And then do that on the bottom as well. And so nice things will happen. That'll give me the limit as h approaches 0. Well, if I multiply the top out, square root of a plus h times square root of a plus h, that's just going to give me a plus h. Then the middle two are going to cancel out, aren't they? Because I'm going to have a plus and a minus. So those will cancel. So that'll leave me just minus square root of a times positive square root of a. That'll be a minus just a, won't it? Negative times a positive is negative. Square root of a is just a. Then the bottom I'll have h. Just going to leave that as is. Because nice things happen on top. The a's wipe out. Then also, since that happened, what else? The h's cancel out, so I wind up with the limit h approaches 0 of 1 over just the square root of a plus h plus the square root of a. Right? All that canceling out leaves me this. H is going to 0, so what happens to this limit? The limit becomes 1 over the square root of a plus square root of a, doesn't it? Because h is going to 0. Well, that's 1 over 2 square root of a. Yeah. If you're just doing it in general, most of the time, your answers are going to come out looking like this, where you have some expressions with a in it, something like that.